Okay, welcome to screencast number 3 for lesson 1 of unit 8, and we're going to talk about the jet stream. All right, first of all, the jet stream. A flight from Seattle to Boston can be 30 minutes faster than a flight from Boston to Seattle. And why is that? It's because of the jet stream. Okay, Seattle is over here, Boston is over here, and when you fly from Seattle to Boston, you're sort of flying along with this polar jet stream, which we're going to talk about. And when you go from Boston back to Seattle, you're flying against it. So if you've ever run track or anything, you know that you can typically run faster if the wind is at your back, or if you're running with the wind, than you can if you're running into the wind. It tends to slow you down. All right. The jet stream. The jet streams are narrow belts of high-speed winds that blow from west to east, beginning at about 7 kilometers up in the atmosphere, all the way up to maybe 16 kilometers up in the atmosphere. So it's important for you to understand that jet streams are not surface winds, okay? They occur high in the atmosphere. Why do we care about what the jet stream is doing? Because these high-speed bands of wind help to move weather systems around, okay? Bring in cold fronts, things like that, okay? Now, just to mention, everything that we've talked about so far in this lesson, your trade winds, your westerlies, your easterlies, okay, these large convection cells that we had on page 424, how the Earth's rotation affects wind, all that stuff. What we've been talking about so far are global winds, winds that circulate on a global scale, okay, worldwide. Okay. The jet stream is also a global scale wind. It goes, they're bands of winds that go all the way around the globe. Okay. All right, there are two main jet streams, the polar jet stream and the subtropical jet stream. Both of them are in each hemisphere. Okay. And the jet streams follow boundaries between hot and cold air masses. Okay. Now, we're not going to get into how exactly the jet stream is formed and why it's there, things like that. That's sort of beyond what we do in 8th grade science, but please understand what they are, okay? They're narrow belts of high-speed winds up in the atmosphere, okay, and know where they're located, okay? You've got the polar jet at the higher latitudes, you have the subtropical jet at the lower latitudes, okay? So A should be labeled the polar jet stream, B should be labeled the subtropical jet stream. All right, why does all of this matter? Well, we need to understand that what happens in one area of the world can influence what's going on in our part of the world, because global winds can carry weather systems, sediment, things like that. Okay, so winds can move things around all over the globe. For instance, over here, they give you an example of sediment being carried away from the Sahara Desert, which is over here in Africa, all the way across the Atlantic Ocean, and it causes haze and dust storms and things like that in Miami, which is all the way across the Atlantic Ocean. So global winds can go quite a ways. Okay. All right. I'm going to go to page 430, and we're going to talk about some local winds. Okay, so everything we've talked about so far are winds on a global scale. Okay, big scale winds. Okay, that are generally occurring all over the world. We have those general bands, the easterlies and the westerlies and the trade winds and all that. Okay, but now we're going to talk about some smaller scale winds, local winds. Okay. So unlike global winds, local winds are the movement of air over short distances. Local winds can blow from any direction depending on the surface features that are in that area. There are two main kinds of local winds that we want to mention. We have sea and land breezes. That's the first kind. And then we have valley and mountain breezes. That's the second kind. Okay. Let's talk about sea and land breezes first. Just a reminder, winds are always named by where they come from. So a sea breeze is a breeze coming from the sea. A land breeze is a breeze coming from the land. Okay? The way this works, land and water absorb heat from the sun differently. Okay? Land heats up fairly quickly. Okay? Water, it takes a lot of heat energy to get water to change its temperature very much. So if you've ever gone to the beach during the day, you have noticed that the sand can be very, very hot, the dry sand, okay? But you go into the water and the water is relatively cool. And that's just because the land and the water don't heat the same. So during the day, the land heats up a bunch and the air above it also heats up. And warmer air is less dense, which creates low pressure, and so that air is going to rise. And as that air rises, air is going to come in and take its place, and that air is going to come from an area of higher pressure. Okay? So the air that's coming in to take its place is coming in off of the ocean or off the sea. That's why it's called a sea breeze. So during the day, you have the wind coming off the water, going over the land, heating up and rising, and you get this circulation where you have descending air over the cooler water and rising air over the warmer land. Well, at night, it's just the opposite. Okay? Not only does land heat up more quickly than water, it also cools down more quickly than water. So at night, it's the land that's cooler, and it's the ocean that's warmer. So the air over the ocean this time is going to be the warmer air, and it's going to rise. Higher pressure air is going to come off the land and take its place, and so the circulation gets set up in the opposite direction, where the wind is blowing from the land out to the water, and that's called a land breeze. Okay? Okay, valley and mountain breezes are sort of similar. They're local breezes. You have high pressure during the day at the bottom of the valley, and that's going to flow up the sides of the mountain to areas of lower pressure. Please understand that winds always blow from high pressure to low pressure. Okay? At night, it's going to be just the opposite. It's going to be higher pressure at the top of the mountains, and it's going to flow down the valley towards an area of lower pressure. Okay? Okay, but those are two types of local breezes, breezes that could flow from any compass direction. Okay? All right. So going over here, wind is the movement of air from areas of higher pressure to areas of lower pressure. Cool air sinks, and if cool air sinks, it causes higher pressure. High-speed wind between 7 and 16 kilometers above the Earth's surface. Remember, we just talked about that. That's the jet stream. During the day, an area of higher pressure forms over the water, because that's where the air is cooler. And because of that, we have a breeze blowing off the sea, and that's called a sea breeze. Okay? So describe how the sun provides the energy that causes convection in the atmosphere and produces wind. Well, the sun provides the heat energy that comes to the earth. The surface of the earth and the atmosphere absorb that energy, and the places where the atmosphere absorbs more energy, it's heated up more. Those areas tend to have air that tends to rise, and other places that are not getting as much heating, those are cooler areas, which is going to be more dense air and higher pressure, and you're going to have winds flowing when you have air from higher pressure moving to areas of lower pressure. Okay, so it's sort of nature's way of trying to rebalance the pressure gradient. It never quite gets there, but that's why we have wind. We have wind constantly moving from areas of high pressure to areas of low pressure, and it's all driven by the sun, because the sun is providing the heat for the earth, but not all areas of the earth get the same amount of heat, and not all types of terrain are heated the same way, because land and water do not heat the same. Okay? All right, so with all this information, you should be able to finish the questions on the lesson review, and that should be it.